All right, so here's a problem similar to 3.10.39 on your homework. And as you can see, I've actually just copy pasted the question directly from the homework this time. So this might be really similar to the one on your homework. It might be the exact same problem. If that's the case, you got lucky, and I'm just going to be giving you the answer here. But this is kind of a tricky one, so hopefully you can figure out how to complete this problem from this example. So what we have is that a light shines from the top of a pole 60 feet high. A ball is dropped from the same height from a pole 40 feet away from the light. How fast is the shadow of the ball moving along the ground 1 second later? Assume that the ball falls at a distance of negative 16t squared in t seconds. Okay, so the question is, what is this? How fast is this x value changing when we're at 1 second later and this ball is being dropped, right? So there's this shadow being projected from this light through this ball onto the ground. So we want to know how fast this shadow is moving. Really, that's our x value. How fast is the x value moving? Now to do this, I'm going to do some fancy trigonometry. What I'm going to notice is that this triangle here is actually similar to the big triangle as a whole. And I'm going to use that information to figure out exactly how fast this is moving. So what I'm going to do is I'm going to look at this angle here. I'm going to call that angle alpha. And since these are similar triangles, that's the same as this angle here. Right? So both of these angles are the same. They're alpha. I'm going to look at the cosine value of that angle. So cosine of alpha. And I'm going to try and figure out how I can represent cosine of alpha. Well, if we remember, cosine is always adjacent over a hypotenuse, right? So katoa, adjacent over hypotenuse. So if I look at the big triangle, my adjacent is my x value, right? And this is just this adjacent leg of this triangle is my x value. So that's x of t. And then adjacent over hypotenuse. Well, my hypotenuse is the entire height, which is the pole, which is 60 feet. So that's 60. But I can also look at cosine of alpha of this smaller triangle here, right? And that's still going to be cosine of alpha. So I know that these things are equal. So if I look at this smaller triangle, adjacent, well, it's going to be 40, right? That's just this lower leg here. We know that that's 40 away from the pole. Over hypotenuse, the hypotenuse is not going to be 60 anymore, right? It's just going to be this little bit at the top. It's going to be how far the ball has fallen. Well, we know how far the ball has fallen. The ball falls at a rate of negative 16t squared. Right? So this, I've just used this cosine of alpha to develop this relationship between these two different triangles, and that's going to allow me to solve for x of t, right? So now looking at this, I know that these are equal, so I can solve for x of t. Just multiply both sides by 60. I get x of t is equal to 2400, that's 60 times 40, divided by negative 16t squared. Now I can actually simplify that a little bit, right? If I divide 2400 by 4, I'm going to get 600, and then if I divide it by 4 again, I get 150. I can bring the negative up if I want. So negative 150 over t squared. And lastly, I'm going to take a derivative, because what I'm looking at is how fast this x value is changing. So when I take this derivative, right, what do I get? Well, I get 300 divided by, and then I use my power rule, right? So I've used my power rule. I've multiplied that negative 2 up front to get 300. And then I subtract 1 from that. Subtracting 1 from negative 2 is negative 3. So I get 300 over t cubed. And then I just plug in 1, because I'm curious as to how fast this is moving at x, or at t equals 1, right, at 1 second. So I plug in 1, I get 300 over 1. That's 300 feet per second. Now, they might want a negative in front of this. I don't know for sure. I know for sure negative 300 works. I believe that positive should as well, since they just say how fast it's moving, which is not velocity, right? It's just speed. So the magnitude of how fast it's moving is just 300 feet per second. I'm not sure if they're going to want the negative or the positive, but that is how you would solve this problem.